by the end of the unit, okay, all this stuff that's in here is going to make more sense. Right now it's probably a little overwhelming because we haven't really seen too much of this, okay? So as we go through 5.1 and then the rest of the unit, you'll see some of this terminology come up again, like leading coefficients, degree, linear factors, and all that stuff. So we'll review it and use the terminology as we go through. But for now, okay, if you read the objective on the board, there's really only one goal. Okay, 5.1 is going to be a long section, but it's to determine the shape and what the end behavior of these polynomial graphs look like. Okay, and so first we need to figure out what polynomials in the equation anyway look like. Okay, so if you look at example 1, do we think that f is a polynomial? Okay, here are your keys. We should have no variable in a denominator or inside of a radical or in an exponent. Okay? The other key is this. The exponents, bless you, should always be whole numbers. Okay? So what do you think? Yes, this is a polynomial. Well, I'm skipping function for now. It'll be okay. Well, we'll see. Degree. Well, it says if no y.
So yes. That's why I thought function would say yes, and then if no, if you put no, then you have to explain why.
Polynomial. Yes or no.
Okay.
If no, we'll explain why. Okay. So this is a polynomial, so we're not going to explain why it's not. Okay. The degree, right here. The degree is the highest power, if it's all multiplied out and it's written as an addition problem. What's the highest exponent that you guys see? 6. So the degree would be 6. This is actually not written in standard form. Typically, we write it in this format where the biggest exponent is first, and then we just go down in order. Okay? So the leading term here would actually be negative 15x to the 6th. Leading coefficient means what's the coefficient of the leading term? So that'd be negative 15. Okay? Now, for G, what do we think? No. Why not? X is in a radical. Perfect. So we're not going to answer anything else. What about this next one? All we care about is x to the 5, x to the first, and these coefficients, as long as they're real numbers, right, we're okay. So this is yes. What's the degree?
5.
What's the leading term? Good. And the leading coefficient? Okay. What about J? Is that one a polynomial? This one is, yeah. Because there's no x in this radical. This is just a real number constant. We have x cubed and x squared, so we're good. What's the degree? Leading term? Okay, and leading coefficient is negative 5. What about K? It is. And if you don't like it in this form, you could just divide. 2 divided by 4 is 1/2, and then this would be negative 1 divided by 4, x squared. Okay, and that looks exactly like a polynomial. What's the leading Or what's the degree? Leading term. Remember, you got to find the one with the highest exponent, right? Sometimes they're written in order, sometimes they're out of order, but we're always going to use the highest exponent term for the leading term. Leading coefficient then is -1/4. Okay, what about p? Why not? X is in the denominator, good. And what about this last one? What do you guys think? These exponents have to be whole numbers. So this is not going to be the polynomial. So this will, how can we say that? X has a 5/3 exponent, which is not a whole number. Okay. I think what they meant here by function is not is it a function, but is it a polynomial? So we kind of did everything we needed to do here. All right. Are there any questions on this first page? So far you just need to be able to identify that's a polynomial, here's the degree, here's the leading term, here's the leading coefficient, and this is not a polynomial. Okay. If you turn the page, you'll notice that for some reason we go from 1 to an empty page to 3, and then 4, and then 5. Basically every page copied except for page 2, which is why you have a separate page. Okay? We saw that and we figured, well, you know what, we got to do that, so let's, instead of recopying the whole thing, we'll just print out this page. Okay? So right now, all I want you guys to do is explore these power functions, basically x to a power, x squared, x to the 4, x to the 5, and just use your graphing calculator just to graph all of these. It doesn't have to be perfect, but just like a quick picture, like what does it look like? You might already know.
Do we need to do the thing where you gotta put at least 3 points?
No, just a quick picture. Mm-hmm. What are the options there?
Well, it's like it says RAM cleared.
Yep.
Press alpha F1 to F4 to locate your equipment. That always happens when you put new
But what else does it say?
That's it. And then it just tells you the kind of calculator. No, it doesn't.
Yeah, yogurt.
Yeah, yogurt spilled like a couple years, like a year ago. And then like sometimes the batteries like it sometimes like comes out and goes back in, I guess, and then it thinks that I put new batteries.
Well, YouTube, you heard it here first. Don't put yogurt in the calculator.
I didn't do it purposely.
Yes.
I spilled yogurt.
Anybody seeing a pattern yet?
Yeah. Same thing.
What's the first one look like? A parabola. What about the next one? Okay, we could have guessed that, right? What if it's to the 4th? It's still a parabola, just a little thinner, right? Here, same thing. Here, yep. What about y equals x? Negative x, other way. X cubed. That one we know from before, right? Negative x cubed just reverses the direction. What about x to the 5? So same as x cubed, just a little thinner. And then this will just reverse it. Okay. So if you can remember, even-powered functions are always going to look like, in other words, bless you, a parabola. Okay, that's going to be half the battle, is knowing what it looks like. Okay, as we get further on in the notes, okay, what's going to happen is we might have something that's let's say to the 6th, and it's going to look just like this, except that right around here it might actually go down, come up, go down, and come back up again. But in the end, it still, starts up high and finishes high. Does that make sense? That's what we mean right over here when we say end behavior. That's what we're talking about. How does it start and how does it end? Okay, so we'll talk more about that, what end behavior is, in a minute. Okay, but for now, look at all your even-powered graphs. What kind of symmetry do you see? So it's got y-axis symmetry. What about all the odds? Origin, yes. Sorry about that. What is the domain for all of these pictures? Good. And now range gets split up, and I think you'll see why. If A is positive, that's the leading coefficient. If we're looking at an even-powered graph, so like this one, right? What's the domain going to be? I'm sorry, yeah, what's the range going to be? 0 to infinity. But if it's negative, they all flip over, right? Good. What about for all the odd-powered functions? What's the domain, or I'm sorry, what's the range? Yeah, all of these go from negative to positive infinity, right? So, all right, now let's talk about end behavior, okay? So here's how we're going to read this. As x goes to negative infinity, that's how you read that. As x approaches negative infinity, here's what you do visually on the graph. Your x-axis is from left to right, correct? So basically what this is saying is, if we were to go to the left, and actually we're looking at an even first, so if we were to look to the left, where's the graph headed? So towards what value? Positive. Does it stop? So it goes to infinity. What if, so now when it says as x goes to positive infinity, so if we're on our x-axis and we go towards the right, it also goes to positive infinity in the y direction. Does that make sense? When we say end behavior, we're talking about what are the y values doing now. Okay? What about for an odd? So like this one. So as we're on the left side of it, we start at negative infinity. But as we go to the right towards positive infinity, the graph is headed towards positive infinity as well. Okay? And so here's what I want you guys to remember. The graph's going to look like this. Eventually, there's going to be some stuff kind of going on in the middle, but it's going to come back up. Okay, that's what I mean by big picture or global picture. It starts up, ends up. What's going to happen in the middle, we'll talk about later. Okay? This one starts at negative infinity, and then as it gets near the middle of the graph, it'll do some stuff. Okay, I know it seems silly, but you'll know what I mean when we start doing it. And then what does it do as it goes to the right? It goes up. Okay, Does that kind of make sense? All right, so let's look at what happens if the coefficient is negative. So for the even graphs, like B or F, right? As we go to the left, where's the graph headed? Negative infinity. And as we go to the right, it's also headed back down to negative infinity. Now for the odds, so like J or L, if they have a negative coefficient, if we go left, we're headed to positive infinity, and if we go towards the right or to positive infinity, in the y direction, we're headed towards negative infinity. Okay. Does this make sense? Any questions on this page? So at this point, you should be able to tell me, yes, this is a polynomial, or no, it's not, and explain why. Yes?
Do those bottom line doesn't need like how it's gonna look like? Like you know how the graph looks?
Oh, yeah, I forgot to do that. Thank you. Let's fill that in. So this one starts where? At negative infinity, does some stuff in the middle, and then it goes back down, right? What about this one? Starts up at positive infinity, comes down, bounces around a little bit, and then eventually it's going to go back down. Okay? Do you guys see what I mean? Like, this is essentially a parabola, just with little details in here. Same thing here. This is essentially like a cubic with little details that we'll learn about later. Same thing with that one. Okay? So that's the other thing now. If I give you any of these, you should be able to just tell me the picture right away. Doesn't have to be perfect picture, but if I say, what's x to the 7 look like? You should all say, oh, it looks just like the cubic one, right? Make sense? Okay. Page 3. So right here is kind of a recap of the end behavior. I'm going to add a little bit to this. So this might be a little confusing unless you're really familiar with the notation. But what this means is for large values of absolute value of x, all that's saying is that we have for large values and small values of x. The graph is going to look just like the leading term. Okay? So for example, if we go back to page 1, we'll talk about it and then we'll do some of these. What's the leading term in this very first row? So this is even or odd? Even, because it's to the 6th power, right? So what's the big picture going to look like? It's going to look something like an upside down parabola. It's going to do some stuff in here and then come back down. Does that make sense? Okay. What about, let's see, let's find another one. Over here, this J graph, what's that going to look like? It's going to look like the cubic graph because the leading term is a cubic term. Does that make sense? Yes.
Wait, so for the first one, for example, you said it's like x to the 6.
Yes.
Well, like if you imagine it, like it's gonna open up.
But there's a negative in front of that, so it's going to open down.
Wait, what was it? Like you just said something about like with the graphs. If you know that it's like cube,
Uh-huh.
then it's gonna open up, or it's gonna be like that, like that.
If it's even, it opens either up or down.
Yeah.
If it's odd, it looks cubic.
Oh, okay, but it's only like that.
Yes.
It's that.
Yes.
The little number is negative, right?
Yes.
Oh, okay. Alright.
Anything else?
I understand.
Okay, good. Let's see if we can put it together now. Okay. So here's some new notation that we're going to talk about real quick, okay? This right here is called a limit. For those of you that are going to take this course and then take the next one, which might be like a business calc or a calculus class, you'll do lots of limits in those classes, okay? And all this is saying is exactly this. Okay, so right here, where I asked you what's going on as x approaches negative infinity, that'd be the same thing as saying the limit as x approaches negative infinity. And then we have, usually what we'll have is an equation in here, okay? Which is why you see f of x on the next page, okay? You just have to be able to recognize, like if I put that on an exam, you just need to remember what it means. Okay, we're not going to spend too much time doing limits, but we're just going to spend time talking about what's happening at the ends, okay? So here, what's this going to look like? What's the highest degree? So negative 3x to the 5, I'm going to say end behavior is like whatever it is for negative 3x to the 5, right? So try to do this without looking at the picture now. If it's odd and it has a negative in front, what's going on if I go all the way to the left of the graph? Where's the graph headed? To positive infinity. Does that make sense? So here we're going left. Okay, if we go left, the graph's headed up, right? Because it's backwards. Here we're headed right. So as we go to the right, what's the graph doing now? It's decreasing, so it's going to negative infinity. You guys kind of see how that works? Okay. What is what term do I focus on here? 4x to the 4. So big picture, what's going on if I'm going left on that curve? Up, so positive infinity, good. And if I go to the right, also going to positive infinity, good. Okay, and if it helps, you can draw little pictures. So it's going to look something like this, right? This one's going to look something like that. This one's going to look like which term? The 2x to the 3rd, which is just like a regular cubic or, yeah, snake, right? So as we go left, where are we headed? Good. And if we go right? And what's the end behavior here look like? Which is essentially an upside down parabola. I'm not writing the stuff in the middle, but we'll get to that later. So if I go left, where am I headed? Good. And if I go right, same thing. Make sense? Okay, we're almost done. This is the last thing we're going to do today. All right, so you'll actually have some time in class right now when we're done to start working on your Math Excel. 5.1, like I said, is going to take us three days. So you're not going to be able, unless you really want to work ahead, you're not going to be able to do all of it today. But you could probably do like the first 5, 6 questions after we've done this now. Yes?
Are the ones from yesterday, and the ones we're getting now, all going to be due,
When we have the test. Yes. But ideally, you should be caught up by tomorrow. Yes?
Did we ever get our test back?
No, I still have people that haven't taken it yet. Yeah. Okay. All right. So for this one, this is just a review of what we did a couple weeks ago. Remember the shifting and all that stuff? So it's just all they're doing is giving you a slightly different parent function. We were used to doing it with x squared or like square root of x or x cubed, right? Here they're saying, well, what happens if it's x to the 4 and then inside I have a minus 7? What is that going to do? It's going to go right 7. Very good. What if I add 8 on the outside? You guys remember what the coefficient does? It stretches, and what does it do? What coordinate? The y gets multiplied by 6. Kind of like this day because it's reviewing stuff that you need to know for the final, right? Okay. Here, same concept, different parent graph. Now it's to the 5th power, right? What's this do? Left 21. Okay, and now here there's a couple of options. I'm going to actually do them both, okay? One option is, since you see a negative, we would reflect over. Think about what we just did. If I have a negative in front, what's it flip over? Yeah, these all flipped over the x if I had a negative, right? So if you ever forget, think of that. Reflect over x. And then the 1/2 is going to multiply y by 1/2. That's one way to do it. Or you can just see this as a whole thing and just say that there's one thing going on, and that's that the y values are getting multiplied by -1/2, which will automatically flip everything over for you, right? Does that make sense? Okay, I think that's it for notes today.